Hello everybody, welcome to a new video. Today we're going to solve the search insert position problem on LeetCode. It's an easy one. So given a sorted array of distinct integers and the target value, return the index of the target is found. If not, return the index where it would be if it were inserted in order. So as inputs, we will have a sorted array of distinct integers and a target value. If the target value is found in our sorted array, we just return the index of the target. And if it's not found, we must return the index if it was inserted in order on the sorted array. We must write an algorithm with O log n runtime complexity. Actually, whenever you see that the array is sorted, the first idea that needs to come to your mind is binary search, and we're going to see how are we going to use it. So now let's see some examples. So here we have 1 3 5 6, the target is 5, the target already exists on the array, so we're going to return its index, that is 2. On the second example, the target is 2, so it doesn't exist on the array, so we need to find its index if it was inserted in order. So 1 is smaller than 2, but 3 is greater than 2, so we put it here in same index as 3, so we return 1. Here, for this case, we have 7. 7 is greater than all the elements here, so we need to put it at the end of the array. That's why we return 4. So here the maximum index is 3, and 7 is greater than 6, so we need to put it at the next index, that is 4. Now let's see some example. Let's see another practical example and how are we going to solve it. So first of all, we need to define some variables. So first of all, we will have left. So let me first add the indices 0 1 2 3. So this is my array and this is the indices, and the first thing is I will have a variable left pointing to the first index, and my variable right pointing to the last element here. And I will have a variable called mid. And actually, every time I want to calculate the mid, it's just the left plus the right divided by 2. And mid is an index 2. So for our first iteration, so the mid is going to be equal to, so 0 plus 3 is 3 divided by 2 is 1. So here will be our mid. So when we calculate our mid, we will have some checks that we need to do. So the first check is we need to see if the value on the index mid is actually equal to the target. And it's not the case. If it was the case, we were going to return mid, but actually it's not the case, so no. Then we're going to check, we need to compare the value on the mid index with the target. Who is greater? What is greater, the target or the mid value? In our case, 4 is actually greater than 3. So here, what are we going to do is the left is going to be equal to mid minus plus 1. If we had like another number that like 2 or 1 that is less than 3, we would have changed our right variable to mid minus 1. Okay, so let's actually apply this change. So my left is going to be equal to mid plus 1. So my left will be here. Okay, cool. Now again, we are on the second iteration. What we need to do is calculate again the mid. So the mid is equal to the left plus the right divided by 2. So 3 plus 2 is 5 divided by 2 is 2. So here in our case, the mid is actually the left. So the left and the mid are both equal. Okay, so now again I need to do some checks. First of all, is the value on the mid index is actually equal to the target? That's not the case. Okay, so we move to the next check. Is 4 we have 5 is greater than 4. 5 is less than 4. So what we need to do is we need to, now the right must be mid minus 1. Okay, so now we remove this. We're going to change our right to here. So we're going to mid minus 1. Actually, mid minus 1, so our right would be here. And actually we stop looping through our through the program if the left is strictly greater than the right. So that means we should stop the program. It's similar to the binary search. And at the end, we return the left. So the last value of left is actually the index where the target value should be inserted on. The left, return the left. Cool, so now let's see how are we going to call that. So as I mentioned earlier, we will need a left variable, a right variable that is equal to the last index. And we will also need a mid value, but we could like calculate it inside of the while loop. And here we need to make sure that the left is actually less or equal than the right. Then we calculate our mid, left plus right divided by 2. And first check if nums mid is actually equal to the target, we just return the mid. If nums mid is greater than the target, what we should do, so nums mid is greater than the target, we need to put the right to mid minus 1, and here put left equals to mid plus 1. Okay, and yeah, and at the end we return the left. Okay, so let's see if it works. Hopefully it works. So run the code. Okay, it's correct. We submit it. Yeah, and it's working. So hopefully you've understood something from the video. Thank you for watching. See you next time. Bye.